So good evening everyone. So welcome to my YouTube channel Math Theorem. So today we are going to see some reductions from Euler's theorem. Okay. So let's see. So reduction from Euler's theorem. Okay. So if Z is a homogeneous function of x comma y of degree n and Z is equal to fu, it means Z is function of u. Then this happens, what happens? X del u upon del x plus y del u upon del y is equal to n times fu upon f dash u. This happens, okay? So let's prove it. Since Z is a homogeneous function of x comma y of degree n, by Euler's theorem, we have by Euler's theorem, x del z upon del x plus y del z upon del y is equal to n times z. Okay, n times z. But but z is nothing but fu. So this implies del z upon del x is nothing but f dash u into del u upon del x, and del z upon del y is nothing but f dash u del u upon del y. So let's say this is equation number 2, and above one you call 1. So substituting 2 in 1, we get what we get. So x in place of del z upon del x, we have f dash u del u upon del x plus y f dash u del u upon del y is equal to n fu. So now we can take f dash u common, then we will have x del u upon del x plus y del u upon del y is equal to n times fu. Now after solving it, what we will get? X del u upon del x plus y del u upon del y is equal to n times fu upon f dash u. So this is proved now. Okay. So this is proved now. Okay. Now we'll see some exercises. So I would like to remark something. Remark If V is equal to Fu, where V is a homogeneous function in x, y and z of degree, and then similarly you can prove that this will happen. Del x del u upon del x plus y del u upon del y plus z del u upon del z is equal to n times fu upon f dash u. So this will happen. So this is also one result. Okay. So now we will see some exercises. Example, if u is equal to log e x to the power 4 plus y to the power 4 x plus y, so that so that x del u upon del x plus y del u upon del y is equal to 3. So let's see its solution. U is equal to log e x to the power 4 plus y to the power 4 upon x plus y we have. Okay, so we can write it e to the power u x to the power 4 plus y to the power 4 x of plus y. Now let's say z is equal to e to the power u x to the power 4 plus y to the power 4 upon x plus y. Okay, now z lambda x lambda y is equal to lambda x to the power 4 plus lambda y to the power 4 upon lambda x plus lambda y. So lambda 4 will come out x to the power 4 plus y to the power 4 upon lambda x plus y. So lambda will be cancelled out. It will be lambda to the power 3. So it will become lambda to the power z x y. So this implies z is a homogeneous 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 function of x y of degree 3 by applying reduction of Euler's theorem. We get what we get. Now here z is equal to e to the power u here, and here z is a homogeneous function of x comma y of degree 3. So we are applying here this, applying reduction of Euler's theorem. So what we will get? We will get x del u upon del x plus y del u upon del y is equal to, here what is here what is fu? Fu is nothing but e to the power u. So derivative what will be this? E to the power u also. So by Euler's theorem we have n times fu f dash u. Here n is 3 because degree is 3. So we have x del u upon del x plus y del u upon del y 3 eu eu. So this is cancel out. So what we have? We have x del u upon del x plus y del u upon del y is equal to 3. This is proved now. Okay. Now example 2. Example 2. If u is equal to sine inverse x plus 2y plus 3z is equal to, so under root x to the power 8 plus y to the power 8 z to the power 8, so that x del u upon del x plus y del u upon del y plus z del u upon del z is equal to nothing but plus 3 tan u is equal to 0. We have to prove this. The solution. Solution. So u is equal to u is equal to u is equal to is sine inverse x plus 2y 3z upon x to the power 8 plus y to the power 8 z to the power 8. So this implies sine u is equal to x plus 2y 3z upon x to the power 8 y to the power 8 plus z to the power 8. So let's say z is equal to zxy is equal to sine u x plus 2y 3z upon under root x to the power 8 y to the power 8 z to the power 8. Now z lambda x lambda y is lambda x plus 2 lambda y 3 lambda z upon, so lambda to the power 8 come out, x to the power 8 plus y to the power 8 plus z to the power 8. So this will be square root. So it will be, you can take common. So this is lambda to the power 4 x to the power a plus y to the power a plus z to the power a. So this is cancelled out three times. So this we have lambda to the power minus 3 zxy. So zxy is nothing but lambda to the power minus 3 zxy. So meaning of what this is, z is a homogeneous function of x comma y of degree minus 3. Now z is equal to sine u, where z is a homogeneous function of x comma y of degree minus 3. So also fu is equal to sine u here is sine u. So this implies f dash u will be cos u by reduction of Euler's theorem. We get what we get x del u upon del x plus y. So this is a homogeneous function in x, y, and z, three variables. So del u upon del y plus del u upon del z is equal to n f u f dash u. Here, what is n here? N is minus 3. So x del u upon del x plus y del u upon del y plus z del u upon del z minus 3 sine fu sine u, and this is cos u. So what we got, this will become tan u. So after solving it, we will get after 3 tan u. So we are done. Okay. So in this lecture, we have seen a reduction of Euler's theorem, and we have done two examples. If you have any problem related to these examples or this concept, you can comment on my YouTube channel. So thank you very much for today's lecture. Thank you very much. We'll see you in next lecture. Thank you very much.